Alright, let's take a look at a word problem. It says, I can use properties of rational exponents and properties of roots to rewrite radical function models and then evaluate real-life situations. So let's see if we can do this. Alright. Let's write this function and do what it asks. It says, a can that is twice as tall as its radius has a minimum surface area for the volume it contains. Alright, so the formula S, surface area, equals 6 pi times the volume of 2 pi to the 2/3 power expresses the surface area of the can with this shape. Okay, so it wants us to simplify this and then write the coefficients, which is any number, that would include 6, 2, and both pi's, to the nearest 100. So let's try this. Alright, so I'm going to take this and rewrite it. I'm going to say S equals 6 pi, and then we'll say times, looks like that's V now to the 2/3 power, and then we also get 2 to the 2/3 and pi to the 2/3. Okay, let's write all that together. So here we go. We're going to say S equals, and I'm going to write it as one big fraction. I'm going to say 6 times 2 to the 2/3, and then we'll keep pi over pi to the 2/3, and I guess we've still got volume to the 2/3. Well, this is pi to the first, so let's write it with a common exponent, a common denominator, so that's 3/3. And I'm going to write this one more time. I'm going to write it over here. Let's just keep 6 times 2 to the 2/3 like that, times pi to the 3/3 minus 2/3, right? Same base, keep and subtract. That gives us pi to the 1/3, and then V to the 2/3. So I'm just going to put that in the calculator. I'm going to put all those numbers in the calculator. So here we go. Now look at this. I've got 6 times 2 raised to the 2/3 power times, let's do, where's our pi on here? I see it, it's right there, pi raised to the 1/3 power. And I think those are all my numbers. So if I hit that, I got 13 I don't know, let's go 13.95. That's pretty close. So I'm going to say the surface area is equal to 13.95 times the volume raised to the 2/3 power. And down here it says, hey, let's plug in a volume. So if my volume equals 440, I'm just going to plug it in. Alright, so I'm going to get my calculator back. We'll write it. S equals 13.95 times the volume, 440, raised to the 2/3 power. So here we go. Let's do it. So we got 13.95 times, what do we say, 440? 440 raised to the 2/3 power. With this calculator, I don't need to put parentheses. If you have an older calculator, you should probably have to put that in parentheses because it'll be down here at the base level. And I think that's good. And it looks like we get about 807 as a surface area in square centimeters. So our surface area is approximately 807 centimeters squared. Oh, one's done. Not too bad. Let's try another. The buoyancy of a fishing boat in water depends on the volume of air it contains. Okay. The radius of a sphere, so we're looking at a circular float, as a function of volume is given by this. So we got the radius as an input, and then volume, radius as an output, and volume as an input. Right. Use the properties of root to rewrite this. Let's rewrite it. Alright. So our radius would equal, that looks like 3 to the 1/3. So 3 to the 1/3 times the volume to, oh, it's not 1/3, is it? Oh, yeah, it is. I see that 3. Alright, I was looking down here and couldn't see an index, but it's because I forgot it was up there. So that's volume. There's a 1 power 3rd root, so 1/3. And then we've got 4 to the 1/3. I could rewrite that as 2, but I don't really need to. And then pi to the 1/3. Well, I don't see anything left to do but actually put this in the calculator, so let's do it. We're going to put all the numbers in the calculator here. So we got 3 to the 1/3 divided by 4 to the 1/3 pi to the 1/3. I'll show you how we put this in. So let's start off with 3 raised to the 1/3 power divided by, and then we're going to put this in parentheses so it divides by everything. 4 raised to the 1/3 power and pi. So pi raised to the 1/3 power. We'll end that parentheses. So that's 3 divided by all that, and we get 0.62035-ish. So we'll say 0.62. So if I rewrote this, we'll just write it down here. Radius is equal to 0.62 times volume to the 1/3 power. Okay. Well, what does it want us to? So it wants us to have a volume of 4.4 cubic feet. So let's plug it in. Radius equals 0.62 times 4.4 raised to the 1/3 power. I don't think I've messed up here at all. I think everything's going okay. Alright, so let's plug that in. So here we go. We got, let's leave that one in there. It's there. So we'll say answer, right, times 4.4 raised to the 1/3 power. No parentheses needed because the power will go first anyway. So it looks like 1.03, which I could say about 1, but my radius is approximately 1.03. And that's it. It's just plugging stuff in. I'm going to close this, and you've got all your notes. I'll see you on Monday. And this is another year, and then I'll see you whenever it says, whenever we're coming back.